RStan and PyStan, and it's an embedded domain-specific language for Stan. So you get a type check API in Scala that you can use to generate Stan. So here's a linear regression example, which I imagine most of you are familiar with. So on the left side, you have the Stan code, which has your data block and your parameters and your model. And there's what the mathematical representation would look like. So if we were translating this into ScalaStan, it would have your data. So you specify val n equals data, which is like on the left side for Stan. And you say it's an int with a lower bound to 0. And then you do the same for y and x. And it's pretty similar to Stan. You can do the same thing for parameters. So you have a parameters block, but in ScalaStan you have a parameter, and then you say what type it is. And then finally, you can specify the model in Scala. And so there's this DSL that says y is run from Stan normal alpha plus beta times x sigma. And so model here is a trait in Scala that provides a DSL that you can use to generate the Stan code. So the goal of this DSL is to be as similar as Stan as possible, so that it's really obvious how the mapping between ScalaStan and Stan works. Because it's in Scala, you get some nice IDE support. So, for example, if you do something that's not type safe, the IDE will likely yell at you if you're using something like IntelliJ. So here, this won't compile, and IntelliJ will even underline it because it's not correct. It also gives you, the IDE will also give you discoverability. So if you're like, want to see what distributions are available, you can just do stan dot, and all this stuff comes up from IntelliJ. And of course, it'll tell you what you need to pass to different functions and distributions. So, how do we get data into ScalaStan? So you specify the data parameters as we did before, just like you would in your Stan model. And then from Scala directly, you can just say your model dot with data, and that's translates the data that you have in Scala land into Stan land in a type safe way, so they'll complain if it's not the right type. And when there's also convenience methods for CSV and R, so you can do both of those as well. And Scala ensures that the types line up, and if you notice n, we never specified it, but Scala knows that it's there, so it sets it automatically for you. So running the model is just .run. So you do results equals model, which is your new model, whatever. Then you set your data, and then you do .run, and it runs the model. You can also give it some parameters, like how many chains you want to run, or what seed to use, and other parameters, like anything. This is built on top of CommandStan, so any of the CommandStan parameters are available. So for getting results out of ScalaStan, it creates this results object, and there's a dot summary that you can use, or you can use some summary statistics or whatever to pull the samples out. So here's another example. I'm sure most of you are familiar with the Stan documentation. So this is an example in there, Neil's funnel. And if you notice, this gets 72 divergent, and 72 iterations end with a divergence, so this isn't good. It's not exploring, the HFC is not exploring down in the neck of the funnel of this model here. So the manual suggests a non-centered parameterization, and if we do that, it does a much better job. So we did this in ScalaStan by introducing two transformed parameters, just like the Stan version. and then we sample from the non-centered distribution. But what's nice about ScalaStan is we can write code that it's more generic. So if we want to do this all the time, for example, we could write a sample version of this that does the non-centered parameterization, and then we just, in our model, use our new function. It's probably not saving any code here, and it's super confusing, I'm sure, especially if you're not familiar with Scala. But the point is you have to do this once, and then hopefully you can reuse that functionality over and over again. So another example, composing models in ScalaStan. So another example from the manual is just simple least squares regression, and you can implement that with this target plus equals minus dot self, and then the least squares regression. In ScalaStan you can do that in a simpler way than this, but I want to show you how you can compose these. So here we have it in a trait, and then we can have like a version of this concrete implementation of this trait. And then we can just use it as least squares down here. But if we want to go beyond least squares, maybe we want to do the ridge penalty, we can do that in the trait as well, and then we have least squares with ridge penalty, and now we have least squares regression with ridge regression. And then we can do the lasso penalty in the same way. So we have another trait here in ScalaLand, and we just do lasso regression as least squares with the lasso penalty. And then we can use that in a similar way as the least squares regression. And combining that, we can do elastic net regression, this is just straight from the manual, where we do least squares with the ridge penalty and the lasso penalty, and now we have elastic net that we can reuse over and over again. So some other features of ScalaStan is we have local variables. Just about everything that's in Stan should be implemented in ScalaStan. I mean, I'm sure there are holes, but most of it's there. While loops. So this is kind of a goofy thing in Scala. Because this is in Scala and it's actually compiled Scala, we can't use the while keyword because it's already a keyword in Scala, so we use loop and when and otherwise. We can do data and parameter transformations and functions. ScalaStan has model and result caching, so we just like RStan, I believe, that if you compile the model and you run it with different data, it can reuse the model. But also it does data caching so that if you change something in your Scala analysis of the run, it doesn't actually even run the model again. It just reuses those results. And it allows you to iterate more quickly. In addition to being able to write using the DSL, you can of course just use ScalaStan like you would RStan or PyStan, and just, well, first you can export the model from ScalaStan into a Stan model, which you could pull into RStan or CommandStan or anything. And you can also use this import thing, or load from file thing that loads an existing Stan model. You lose some of the type safety doing this, but it allows you to reuse other models that people have come up with. Some future directions for ScalaStan is higher level API, so we don't necessarily want to think about writing transforms and everything. We just want to think about regression or whatever we're doing, so it has some higher level notion. And of course, because ScalaStan actually pulls Stan into a DSL or into a syntax tree internally, we can do code transformations on Stan code Scala land. So that means we could do like automatic reparameterization, for example, or automatic extraction of transforms, or even just traditional compiler optimizations applied to StanCode, which may or may not make sense to do, I don't know, but it would be something that you could possibly do. So that's all I have, really. The ScalaStan GitHub repository is available if you want to try it out, and I encourage you to do so. It's still pretty early, but if you have any suggestions, I would be very happy to hear them. Also, CIVO is hiring engineers and data scientists, so I wanted to throw that up there. So if you're interested, please let us know. That's it. Any questions?
Sorry, one question. You said that Scala is a mixture of object-oriented programming language as also a functional programming language. So
right.
I have used in Scala higher order functions and lambda expressions. How do you deal with does ScalaStan translate lambda function, anonymous function like C#, for example, to Stan? Stan doesn't have it.
So ScalaStan doesn't translate arbitrary Scala code into Stan. It's just whatever limited things are in this DSL. So it doesn't do higher order functions, but you can use higher order functions to generate Stan code. I don't know if that answers your question.
But you're planning to implement something like into ScalaStan, implement the way to higher order function predicate lambda expression in order to make. For example, I use an earth-time code for F-query predictions, and I will need a high order function, and Stan didn't have it.
So I guess I don't have an exact answer to that, but I think that's a direction that supporting more stuff like that is something we're interested in doing.
So one thing we're going to do is we're going to be adding higher order functions to Stan because C++11 added closures. So we're going to be able to take functions and be able to do lambdas that just automatically bring in the data and parameters. I don't know how that'll interface with Scala. But I had a real question about the ScalaStan as well. So in terms of type inference, it looks like you're declaring whether something's a transform parameter or whether it's a generated quantity.
Right.
Do you think there would be a way to leave that open? Because one of the nice things about SlickStan, I know Maria got delayed. I think she's going to be talking tomorrow or the next day or something. And that actually infers where things should go in the block, which is a source of inefficiency.
Right.
And I can also answer all those last 4 questions with yes.
Yeah, so doing things like that is something that hopefully we'll be able to do with this AST in the future, pull the transforms out, which I think would be really cool to try.
How specific do you think your code with Scala is for just doing this against any statically typed language? I'm thinking of there's a computer algebra system called Axiom or FreeCAD that's also statically typed. I think the same approach is make an Axiom standard.
Yeah, it seems like that should be possible, yeah. What's nice about Scala is you can overload all the operators and everything, so it looks pretty similar. But
okay, cool.
In the back. Hold on.
Hey, can you go back to the slide where you do the non-standard parameterizations? I was trying to figure out if you have to do it on everything in the model, or if you can do it on one parameter at a time.
you should be able to do it on one at a time. Actually, a previous version of this slide kind of alluded to that, but I took it out. So you could have multiple of these sample methods and have one that's sample centered and one that's sample non-centered or something, and then you could use a different one for each of these parameters.
Cool.
Is that what you're getting at?
Yeah. Thank you.
Any other questions?